Hello students, welcome you all to this next session. In this session, we are going to discuss about quadratic equations, which is in your second part of Karnataka SSLC syllabus. So before we get into the core of the quadratic equation, let us see what is actually an equation is. Because many of you, if I ask you what is an equation, sometimes you may feel it is difficult to answer. So let's get a clear idea of what an equation is. Now let me give a small hint. So if I take a plus b whole square is equal to a square plus b square plus 2ab. Okay, so this is an expression which you might have seen in your previous classes. You call this as an identity. Actually, this is called an identity. We are going to discuss two different terms. One is an, so this is an identity. So what do you mean by identity? Identity is a mathematical expression which will be valid for all the given values. Means here the two unknowns are a and b. Whatever you give the values of a and b, the LHS will be equal to the RHS. So such kind of expressions are called identities in plural and identity in singular. But now we are going to discuss an equation. So what is an equation? An equation is an expression which will be valid for some particular values itself. For example, so if I say 2x plus 5y equal to 0. Now this is an equation. Now again, in an identity you have LHS equal to RHS, but usually an equation is equal to some value, or it may be the right hand side is 0, and you might ask to find the values of x and y. Okay, so now before that, now there are many types of equations. First we are going to see the basic equation before we going into the quadratic equation. One is the, let me call it as linear equation. So linear equation is an equation of single variable or single degree. So a linear equation in single variable is, the general form is ax plus b is equal to 0. Let me take it as equation 1. So this is a linear equation in single variable x. Here the variable is x, where a and b are real numbers. Remember, for a linear equation, whatever the coefficients are for x and the constant, the term which is independent of the variable is called a constant, and here a is an coefficient of x. Okay, so a and b should be real numbers, and always remember a should not be equal to 0. If a is equal to 0, then this expression is no longer linear. Remember, this is a linear equation in one variable. To solve the linear equation in one variable, one equation is enough. Example, let me take an example. I have 2x plus 4y equals to 0. Now this is a linear equation in one variable. How do I solve it? So I take 2x is equal to, bring 4 to right hand side, you will get minus 4. Therefore x will be minus 4 by 2, and that is nothing but minus 2. So it is easily to solve a linear equation in one variable just by taking one equation. Okay, now let me go to the linear equation in two variables. Now this, the general form is ax plus by plus c equal to 0. So this is the, I told you, this is ax plus by is equal to 0 is the general equation of the linear equation in one variable. Now ax plus by plus c is equal to 0 is a linear equation in two variables. Here the variables are x and y. Now when they give you the linear equations in two variable, always remember you need two equations to solve the linear equations in two variables. This type of equations we see in pair of linear equations in the other chapter. Similarly, if you want the linear equation in three variables, ax plus by plus cz plus d is equal to 0. So this is a linear equation in three variables. So the variables are x, y and z. Remember, your a, b, c, d all are real numbers. So we can see here why we call linear equation is the power of x, or the degree of x, or the degree of the variable in each of the equation is 1, means it is x power 1 or y power 1 or z power 1. When the power or when the degree is 1, we need not specify the degree because it's understood it is 1. So we are moving on to the next expression called when the degree of the variable is more than 1. Okay. So remember, here we come across an equation, let me say general equation as ax square plus bx plus c is equal to 0. Very important equation. This we consider the general equation of the quadratic equation. Let me call it as this equation is star, because this is an equation we will be solving in throughout this chapter. This is the general form of quadratic equation. Here remember, the unknown variable is x. X is the variable and the coefficients, a is the coefficient of x square and b is the coefficient of x and c is the constant term here, means it is independent of x. So we have a, b and c all will be the real numbers. So this is the symbol for real numbers and we know that this means belongs to. Okay. So a, b and c, see these are real numbers. If I give you an example, I can say 2x square plus 3x plus 4 is equal to 0. Okay. We can see here this is a quadratic equation, or it's a second degree equation in single variable. Okay. Throughout the chapter we will be dealing with second degree equation of single variable. If you might be asking, sir, what happens if I have a double variable quadratic equation, and there you get different type of graphs like polynomial, what do you say? We say it parabola, ellipse, hyperbola. So these kind of equations we see the quadratic equation of two variables. We see there that in conic sections. In one way or the other, even the equation of the circle, you might have read it. Actually, the equation of this circle, x square plus y square is equal to, you might say, r square. So this is the general equation of this circle with center at 0, 0 and radius r units. So we are not going to deal this equation here because this is a quadratic equation in two variables. But in this chapter we are going to deal with the quadratic equation in a single variable. Throughout the chapter actually we are going to see the variable as x. But in some cases the unknown variable may be p, the unknown variable may be m, the equation may be in terms of m. So however it is, but in your textbook it is all in terms of x square. Okay. So what is a quadratic equation? An equation of the form ax square plus bx plus c equal to 0, where a, b, c are real numbers. Remember, in this case a should never be equal to 0. My b can be 0, that is coefficient of x can be 0 and the constant term can be 0, but the coefficient of x square should never be equal to 0, because what happens if the coefficient of x square is 0? Actually, when you put the a is 0, this term vanishes, so the equation is no longer a quadratic equation. So that is why the one main condition for this equation to be quadratic equation is a should not be equal to 0. Okay. So b can be equal to 0 and c can be equal to 0. Okay. Now you have come to know what is a quadratic equation. Okay. Now there are two types of quadratic equation. One is pure quadratic equation, the other one is Yes, impure? No, it is adfected. The second one is called as adfected quadratic equation. Always remember, okay, the pure form of quadratic equation is, it is ax square plus c equal to 0, or ax square equal to 0. That means the x term is not there. The term which does not have the x term is called the pure quadratic equation. Okay, and the term we have ax square plus bx is equal to 0. You have a constant, or you may say ax square plus bx is equal to c. So this is a quadratic equation which is adfected quadratic equation. In your previous syllabus, sometimes you used to ask for 1 mark question, identify the pure quadratic equation and the adfected quadratic equation. Okay, so always remember the general form of quadratic equation is ax square plus bx plus c equal to 0. Okay, in this term, if the x term is absent, then that equation is the pure quadratic equation, and if the x term is present, and that type of quadratic equation is called the adfected quadratic equation. Okay, so we'll see a few examples which has been asked in your previous year's exams. Now we can see there is one question asked in June 2009. In a quadratic equation, ax square plus bx plus c equal to 0. Okay, that is the general quadratic equation I have. I have the condition given is, I have ax square plus bx plus c equal to 0. This is the quadratic equation. The condition is, if a is equal to 0, he is asking you, in this equation, if a is equal to 0, then it becomes what? So what happens if a is equal to 0? Just now I have told you, if the term a becomes 0, then this entire term vanishes. So my resultant equation will be bx plus c equal to 0. It's very clear, the highest degree of x is 1. Therefore, this is a linear equation or simple linear equation. So the options given there are this, whether this, that means the general equation with a equal to 0 is pure quadratic equation, adfected quadratic equation, simple linear equation, and second degree equation. Remember, this is when the coefficient of a is actually the coefficient of x square. When the coefficient of x square is 0, then the quadratic equation reduces to simple linear equation. Okay, so that is the solution for this question. Okay, now I have another question which has been asked in June 2011. So okay, so that the question is, I have x plus 1 by x is equal to 3 is in the form of adfected quadratic equation, pure quadratic equation, linear equation, or simple equation. Whenever you have the equation like this, it is always better for you to simplify the equation and get it into regular quadratic form. So how do you do it? So cross multiply or take the LCM. If you take the LCM on the LHS, the LCM becomes x. So here the LCM is 1, denominator is 1. So 1 into x is, I multiply that x here. So I have x square plus 1 is equal to 3. Now I will cross multiply. I will get x square plus 1 is equal to 3 into x. So it is 3x. So finally I have, if you bring it to left hand side, it is x square minus 3x plus 1 is equal to 0. Now this is the resultant equation I have. Looking at this, can I, of course this is a quadratic equation. Now, is it a pure quadratic equation? Yes, Priya? No. Why? The reason is, I have an x term. Any quadratic equation in which the x term is present is called the adfected quadratic equation. So for this question, the right option or the right answer is first one, which is adfected quadratic equation. Okay. Now there is another question which has been asked in April 2014. The question is, the pure quadratic equation in the following is. Okay, I repeat once again, the pure quadratic equation in the following is. Okay, so there are 4 equations here. There are 4 equations. One is x plus 1 by x is equal to 4. If you take the LCM, it is very much clear that this equation is not a quadratic equation, because these two, the previous question was x plus 1 by x is equal to 3, but here it is x plus 1 by x is equal to 4. This will be the adfected quadratic equation. Okay. Now, if you consider B, okay, there is another equation I have, x plus 1 by x equal to 0. You may say that this is also not pure quadratic equation. You may say that this is also an adfected quadratic equation. Okay, let's check. Okay, if you take the LCM, I'll get x, and the numerator will become x square plus 1 equals to 0. Now, if I cross multiply, I'll get x square plus 1 is equal to x into 0 is 0. You can see here I have an equation x square plus 1 is equal to 0. So, do you have x term here as Vinuta? No. So, because the term x is absent in this equation, this is a pure quadratic equation. So, if you want to check the other 2 options also, it's very clear. I have 3x into x minus 1. So, 3x into x will be 3x square minus 3x into 1 will be 3x. So, in this equation also I am going to get the x term. So, this is not the pure quadratic equation, neither this. Okay. So, if why this is not a quadratic equation? Because this is not pure quadratic equation. This is not quadratic equation at all, because if you take x to the right hand side, you just have 2x minus x, means it's a linear equation. Okay. So, this equation is not quadratic at all. This is adfected equation. This is not a quadratic equation at all, and this is your, again it's an adfected quadratic equation. Therefore, the pure quadratic equation is x plus 1 by x equal to 0. Okay. So, I hope now we have got an idea of what is a pure quadratic equation and what is an adfected quadratic equation is. Okay. Now, we are going to move on with one of the exercise problems which you have in your syllabus, which says check whether the following quadratic equations are quadratic equations or not. E will be given with some equations. Now, it's my duty to check whether it is quadratic equation or not. Okay, we'll go forward. Fine. Okay, there are a few more equations we are going to see before we get on to the exercise questions. Now, there is one more question. In an equation ax square plus bx plus c equal to 0, we know this is the general equation. If b is equal to 0, remember once they had asked you in ax square plus bx plus c is equal to 0, if a is equal to 0, I told you the equation becomes what? Linear equation. Yes. Now, in an equation ax square plus bx plus c is equal to 0, what happens if b is 0? Remember, if b is 0, the resultant equation will be ax square plus c equal to 0. So, this type of equation, I told you the coefficient of x is b. So, if b is 0, x term is 0. So, if there is no x term, then that quadratic equation is called pure quadratic equation. So, the options given are adfected quadratic equation, pure quadratic equation, linear equation, and simultaneous equation. Okay. So, the right option here is this is a pure quadratic equation if b is equal to 0 in your general equation. Okay. So, we are going to move on with the next one. I have another question which has been asked in March 2008. The question is select the pure quadratic equation. Now, we can see here in the first equation 2x plus 5 is equal to 13. This is linear equation. Now, second one x square plus 5 is equal to 26x. I have an x term here, so that is not pure. Now, if you take x square plus 5x, this is not an equation at all. Okay, this is just an expression, because if I have to say an equation, then it should be equated to something. So it is not equated at all. So this is not an equation. Now if you check this, I have x square plus 2 is equal to 3, or if you take 2 to right hand side, I'll get x square is equal to 1. So this is an example of pure quadratic equation. Okay, so if they give you an equation like this, it's very easy to get an 1 marker question. Now there is one more question over here. So remember, if an equation has only one root, okay, then the equation is, now there are three terms we are going to see in the next thing. One is root of the equation, or we can call it as the zero of the equation, or we can call it as the solution of the equation. For all the three, it means same, means which if that means if an equation has only one root or only one solution, then the equation is, I have already told you, if an equation has a single solution, then it is a linear equation. Okay, so if an equation has a single root, then it is a linear equation. So the options were given are quadratic equation, linear equation, cubic equation, and simultaneous equation. Remember, the single root means you have a linear equation. Now one more question. Parabola is a curve obtained from linear equation, cubic equation, quadratic equation, and simultaneous equation. So I just told you parabola comes under conic sections, where I have 4 different conics. One is circles, the other one is parabola, ellipse, and hyperbola. There are 4 different conics. All those comes under quadratic equation of 2 variables, 2 unknown variables, x and y. So parabola also comes under it. So it comes under the quadratic equation itself. So the options given are linear equation, cubic equation, quadratic equation, and simultaneous equation. So the right answer for this is quadratic equation. Okay, so we are going to see some equations, and we are going to check whether it is quadratic equations or not. There are 4 equations which have been solved in your textbook as worked examples. X minus 2 whole square plus 1 is equal to 2x minus 3. Since this has already been solved, I am not going to solve these equations. We can see definitely that this is a quadratic equation. X into x plus 1 plus 8 is equal to x plus 2 into x minus 2. Okay, you can check to look. Always don't judge a book by its cover in the same way. You should not judge an equation just looking at it. We have to solve it and then come to the conclusion. Okay, similarly there is a third equation, x into 2x plus 3 is equal to x square plus 1, and the fourth one is x plus 2 whole cube is equal to x cube minus 4. So I am not going to solve these equations because this has already been solved in your worked examples. So let's see the questions in the exercise 4.1. Okay, so this is in your second textbook. The first exercise, first question is, so the question is like this. I have x plus 1 whole square plus 1 is equal to 2 into x minus 3. Now this is an equation. I want to check whether this is a quadratic equation or not. Let us simplify the equation and then come to the conclusion. Now this looks like my form a plus b whole square formula. We know that a plus b whole square is a square plus b square plus 2a into b. Okay, plus 1 is equal to, if you simplify this, this is 2 into x is 2x, minus 2 3s is 6. So this is x square is x, 1 square is 1, plus 2 into x into 1 is 2x, plus 1 is equal to 2x minus 6. So you can see here I have x square plus I have 2x here, 1 plus 1 is 2. If you bring the terms on the right hand side to left hand side, I'll get minus 2x plus 6 is equal to 0. You can see here plus 2x and minus 2x gets cancels. I'll get x square. This is plus 2 and plus 6. So x square plus 8 is equal to 0. This is very clear, a quadratic equation, and in specific a pure quadratic equation. So this is a pure quadratic equation. Now similarly, let us check the second one. The second one, the equation is x square minus 2x is equal to minus 2 into 3 minus x. Okay, so let us simplify. So x square minus 2x is equal to minus 2 into 3 is minus 2 3s are 6. Now minus of minus is plus, 2 into x is 2x. Bring the terms to left hand side. I'll get x square minus 2x plus 2x becomes minus 2x, and minus 6 becomes plus 6 is equal to 0. Now if you simplify this, you will get x square minus 2x and minus 2x, we get it as minus 4x plus 6 is equal to 0. So this is an unaffected quadratic equation. Okay, fine. Now let's go to the third one. You can see here the third equation is, I have x minus 2 into x plus 1 is equal to x minus 1 into x plus 3. Okay, let us solve this. So x into x is x square plus x into 1 is x. Now I have minus 2 into x is minus 2x, minus 2 into 1 is, it is minus 2. So this is equal to, similarly, x into x is, this is x square plus 3 into x is 3x, minus 1 into x is minus x, minus 1 into 3 is minus 3. Okay, I have x square, this is minus x minus 2, that is equal to x square plus 2x minus 3. If you bring the terms to left hand side, I'll get x square minus x minus 2 minus x square minus 2x plus 3 is equal to 0. It's very clear. Your plus x square and minus x square gets cancels, and minus 2x minus x is, I'll get minus 3x, and minus 2 plus 3 is plus 1 is equal to 0. It's very clear. The x square term is absent, so this equation is not the quadratic equation. Is it clear? Fine. Okay, we'll go to the fourth question. I have x minus 3 into 2x plus 1 is equal to x into x plus 5. So simplify this. X into 2x is 2x square plus x into 1 is x, minus 3 into 2x is 3 2s is 6x, minus 3 1s is 3. That is equal to x into x is x square plus 5 into x is 5x. Now if you bring it to left hand side, I'll get 2x square, and this becomes minus x square. Okay, so 2x square minus x square, so this is plus x minus 6x. Okay, and bring this 5x also to left hand side, minus 5x minus 3 is equal to 0. I brought all the terms to left hand side. Now we can see here 2x square minus x square is clearly x square. Now I have minus 6x minus 5x, that is minus 11x plus x. So it is minus 10x minus 3 is equal to 0. Okay. So to look, these equations may look like linear, but this is a quadratic equation, right? So in this way, you're going to solve the equations and check whether they are quadratic or not. Now similarly, there is another equation, sixth one. I have x square plus 3x plus 1 is equal to x minus 2 whole square, right? So left hand side is already solved. So x square plus 3x plus 1 is equal to, use your a minus b whole square formula. So it is a square plus 2 square is 4 minus 2ab. So 2 into x is, I'll get minus 4x. Now bring all the terms to left hand side, or it is understood you can x square are on either side of the equation equal signs, so it gets cancels. So if you bring the remaining to left hand side, I'll get 3x plus 1, this becomes plus 4x minus 4 equal to 0. You need not solve this because the x term gets cancels. We can conclude saying that it is not a quadratic equation. You can see here this becomes a linear equation. So 3x plus 4x is 7x, and minus 4 plus 1 is minus 3 equal to 0. So clearly this is not a quadratic equation. Okay. Now we are going to solve one more equation of cubic equation. Okay, I have the seventh one. I have x plus 2 whole cube is equal to 2x into x square minus 1. Now this is of the form a plus b whole cube. I hope few of you remember the formula and few of you might have forgotten it. Okay, I'm going to write the formula. A plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. You should remember the formulas. If you have forgotten it, then it would be a loss for you. So I'm going to solve this left hand side using this formula. So a cube will be nothing but x cube plus 3 times x square into b is 2 plus 3 times x into b is actually 2 square plus b cube, that is 2 cube. This is nothing but 2x into x square will be 2x cube minus 2x into 1 is 2x. Okay, so see what happens. Now I have x cube plus 3 2s are, that is 6x square plus 2 square is 4, 4 3s are is 12x, okay, plus now 2 cube. So 2 cube is not 2 3s are 6, but 2 into 2 into 2, 2 multiplied 3 times, so that is 8. Okay, so this is nothing but 2x cube minus 2x, right? If you bring everything to left hand side, see what happens. Actually I'll get better, we can take it to one side, you can take it to left hand side itself. So I'll get x cube plus 6x square plus 12x plus 8 minus 2x cube plus 2x equal to 0. So see the x cube term, I have an x cube term is x cube minus 2x cube, so that becomes minus x cube. I have single x square term plus 6x square plus 2 plus 12x minus 2x is plus 10x plus 8, okay, this equal to 0. Now it's clear that this is not a quadratic equation, rather it's a cubic equation. The reason is the highest degree of x is 3. You should not look at, sir, you may say, sir, the x square term is there, but in a quadratic equation the highest degree of x is 2, but here I have an highest degree of x is 3. So this is not a quadratic equation, rather this is a cubic equation. Okay, so this is how you're going to check whether the given equation is quadratic or not, or you can also identify the given quadratic equation is pure and adfected quadratic equation. Now we are going to see a small definition called zero of an equation, or you can also call it as solution of an equation, or you can also call it as root of a quadratic equation. So what do you mean by root of a quadratic equation or solution of a quadratic equation? All are one and the same. Now I told you the general equation of quadratic equation is ax square plus bx plus c is equal to 0. Now I told you this is a quadratic equation, so definitely a linear equation will have one solution and a quadratic equation in single variable will have two solutions of x, means two values for x, okay, and that values are called the root or the solution or the zero of the quadratic equation. Let me say alpha, a non-zero real number alpha, okay. So if this value satisfies the equation, that is if I get alpha into x square plus alpha into x plus c is equal to 0. If a constant satisfies the given quadratic equation, then this value alpha is called the root of this quadratic equation, okay. I am just dealing with a single root, but always remember you are going to get two roots in a quadratic equation. Sometimes you may feel like getting one root, but it would be a plus or minus, and we are going to see that in detail in the next sessions, okay. So remember, what is a zero or what is a root of a quadratic equation? Root of a quadratic equation is nothing but the solution of the quadratic equation. The value, a non-zero real number which satisfies the given quadratic equation, is called the root of the quadratic equation, okay. Now there are many methods, okay. There are many methods of finding the roots, okay, the roots of the given quadratic equation. You can find the roots of the quadratic equation in many different ways. So the first way is we call it as factorization method. The first method of finding the quadratic equation is factorization method, and the second method is completing the square method. We call it as completing the square method, and we have another method called formula method. We have a special formula to find the solutions of the quadratic equation. So I have a factorization method, completing the square method, formula method, and finally I have another method called graphical method. That means I can solve the given quadratic equation using graphs. Okay, so let us conclude the session with this. In the next session we are going to see one by one how we are going to solve quadratic equation through factorization, through completing the squares, and through formula method. Okay, so it's a very simple method, and I hope you have understood the class, and we'll meet again in the next session. Until then, take care and bye everybody.